Hi everyone, I'm Zhengdong. Maybe you've read the paper that you've been given, but does anyone want to guess what this is? Just shout it out. Shout it out. Yes, the galaxy. Okay, so it doesn't look very good, right? But so my talk is on teaching a computer to recognize galaxies. And in the background, you see a really beautiful picture of the Pinwheel galaxy taken by Hubble. But unfortunately, most of the, and we have tons of different types of galaxies. So when we talk about teaching a computer to recognize galaxies, we're talking about teaching it to say, this galaxy is spiral or elliptical, and all these different kinds of shapes. But like the first picture, as I mentioned before, it's unfortunate that most of the pictures we have of galaxies are not as pretty as the second picture I showed, because they're either really far away, or they're obscured by dust, or simply that there's not enough time to get the light from these galaxies because the telescopes are so busy, and they're busy taking pictures of a lot of galaxies instead of just really good pictures of one galaxy. And there's actually a lot of galaxies. You probably already know this, but so this is the Hubble Ultra Deep Field, and each one of these dots is one entire galaxy. It's not just a star. And the size of this picture up on the sky would be as if you got a 1 millimeter by 1 millimeter square of paper, and you held it a meter away from you, and you looked up at the sky. And that's how big this picture is up on the sky, and it's not even complete with all the galaxies that are shown in the picture. And so it's a really big problem to be able to classify all of these galaxies just by hand, right? So the way we try to do this through computer science is through neural networks. And so this is like an interpretation of what neurons look like in your brain. So if you get a human to look at a picture of the galaxy and you say, this galaxy has spiral arms, so it must be a spiral galaxy. Something is happening in your brain with these neurons that are firing. And they're telling you that this looks like a spiral arm, so I'm going to guess that this is a spiral galaxy. And we're trying to replicate that with computers. So just as an example, we're all here today at this CS demo day, and you might have thought about, maybe I want to come to this, maybe I don't want to come to this, maybe I have to come to this. What kind of things happen in your brain if we just simplify it down to 3 factors, such as first, what's the weather like today? And we turn that into just a number, like the temperature in degrees. And then we remember that number. And also maybe like how many friends are with you today? Maybe there's like you have 6 friends also going to this, or just 1 friend. And then finally, how interested are you in computer science? And you put this on a scale of 1 to 10. And so you have all of these numbers that represent different factors of why you should or should not come to this CS demo fair. And then you decide, well, maybe if the weather's above a certain threshold and I have friends that are coming with me, I'll decide to come. But maybe I think that weather is really, really important to where even if I'm really interested in computer science and I have a lot of friends coming, I still end up with not coming. And hundreds of these different factors go into this big network that we create. And all of the properties of the galaxy, such as maybe how fast they're forming stars or how fast they're moving across the sky, go into different numbers that go into the hundreds of different layers that we talk about. And through these layers, we can do lots of math and end up outputting just a prediction of whether this is a spiral galaxy or an elliptical galaxy or irregular or something like that. And there's been a lot of different uses for these. So the first one is classification. So these are pictures from a network that I did, but basically everyone has done this before. So at the top you can sort of see the spiral arms, while lower down in the middle you see ellipticals, and then at the end you see more irregular type galaxies. But other cool things that are sort of the state of the art in terms of using machines to recognize galaxies include things like recovery. So we get this really terrible picture of a galaxy from a telescope, and as humans we can say, oh, this is a really blurred picture of a telescope. But we can teach the computer to say, based on previous images of galaxies, what kind of things would you fill in for the pixels that we don't have? And they can recover the galaxy image to be higher quality that we can use to make more scientific conclusions. And then finally, we can even generate our own galaxy. So these are using generative networks where you give it a bunch of pictures of galaxies, or maybe even Pokemon, and it will generate new Pokemon or generate new galaxies. And these are completely computer-generated galaxies. I think right now most of this is just for fun, though. And so, okay, why are we doing this other than that it's fun? So if you imagine that this is us and there's a galaxy very, very far away, what do we measure the distance between us and galaxies with? Just shout it. Yes, exactly. So light years, right? So if the galaxy exploded far away, how long would it take for us to see it?
1 year.
1 year, if it's 1 light year, right? So what does that mean? It means that if we have tons of galaxies around us, some closer and some farther away, then what does it mean for the ones like if we're looking at galaxies farther away, what does that tell us about how old they are?
They are older than the galaxies that you can see that are closer.
Yes, exactly. So the farther away we look, the farther back we are looking in time, right? Because they're so far away that it takes time for the light to travel to us. And when we have a lot of galaxies, by looking at it with computers, we can generate this plot of like, oh, so many billion years ago the galaxies were just like tiny dots, and then they formed disks, and we can see how galaxies evolved. And so the moral of this story is not necessarily why you should look into galaxies, but why you should use computers for these really big data tasks, right? So maybe you have a lot of homework or something, or you have a big job as like you're teaching about astronomy, but you have to spend a lot of time looking at galaxies to tell yourself whether the galaxy is spiral or elliptical. In fact, you should use a computer to teach you to do this and save yourself a lot of time. And also that even maybe you don't really like computers a lot, you should still do computer science because you can use computer science to let you do more things that you want to do. So for example, if you're a doctor and you like being a doctor but you don't like looking at pictures of brains and you want to see if someone has something bad in their brain, you can just tell a computer to predict it for you. Or maybe you want the perfect bracket for March Madness, and you, instead of thinking a lot and going through pages and pages of statistics, you can train the computer to look through all these statistics for you and tell you who's going to win the next basketball match. And do other stuff, but also know computer science. Thank you.